Hi, everybody. My name is Manjot, and I would like to welcome you to the BGSA workshop for streamlining bioinformatic workflows with Nextflow and Docker. So, who am I, and why should you listen to me on this topic? Well, in my day-to-day, I'm a software developer. So I work as a web developer for a bioinformatics company where I make all kinds of products revolved around bioinformatics solutions for our clients, whether these be workflows, applications. Uh, I have expertise in multiple languages, frameworks, and infrastructure, all towards the ends of bioinformatics. In terms of my background, I actually studied here at the University of Waterloo, where I focused in microbiology, and then I did a master's at Waterloo again, but I focused more so on bioinformatics, and that really laid the foundation for some of the skills that I have today and some of the skills that I'll be teaching you in this workshop. So let's talk about the structure of the workshop. It's going to be split into four parts. First, we're going to have our introduction, where we're going to talk about the basics of bioinformatic workflows. Then we're going to get into Nextflow, what is it, how is it used, and then actually try it hands-on. We'll do something similar for Docker, and that'll lead us to a conclusion where we can summarize what we learned and see what resources are available to take the skills that you learn in this workshop further. And so, why should you care? Why does this matter? Well, the reason why we want to streamline our bioinformatic workflows using these tools, write modern workflows, is we want our workflows to follow these four principles. We want them to be simple, we want them to be efficient, collaborative, and powerful. So when we say simple, we want to be able to integrate multiple tools easily and run workflows seamlessly across multiple different environments. We want to reduce the amount of troubleshooting, the amount of bug solving that we have to do with our workflows, therefore increasing productivity. We want it to be collaborative. So if we can standardize workflow creation as well as the maintenance, not only is it easier to share, but it's easier to make more complex workflows and create a community around some sort of analysis. And lastly, we want these to be powerful. We want scalability, reproducibility, and portability with little to no effort on our ends. And so these are all the kind of things we'll see as we get through this workshop. So what will we learn? Well, we'll learn the fundamentals of bioinformatic workflows. We'll learn how to create and execute workflows in Nextflow. Then we'll see how we can make those workflows portable using Docker. And then finally, we'll see how in little tidbits throughout the workshop, how we can apply software design principles to our workflows.
And so a prerequisite for this workshop is that you have either a GitHub or GitLab account. And this is necessary to access the gitpod environment, which we will use to do the hands-on sessions.
And so who is this intended for? Well, researchers, students, and really any sort of data scientist or software engineer that might be interested in applying these kind of skills. So let's get into it. So what exactly is a bioinformatics workflow? Well, we can think of it as a series of interconnected steps that are organized to complete a task or process. And if we think about what the key components of a bioinformatics workflow are, they can be thought of as first and foremost the data input. So the raw data collection, which could include genomic sequences, protein structure, or other biological data. And once we have those inputs, we can begin to process them by cleaning them, organizing them, and formatting them so that they're fit for analysis. The actual analysis portion typically will involve multiple computational tools and algorithms so that we can extract meaningful insights. So these tools are very specific to the analysis that we want to conduct. Once we have our results, our outputs, we want to understand and contextualize them, and then finally document them using visualizations or summaries. So how do you write a workflow? Well, traditionally, it's done using custom scripting languages. So we think of languages like Bash, Python, and R. And really all we're doing is gluing together different tools. We're not actually writing any of the logic. It's very rare that you'll see anything like that where each of the analysis portions are completely custom, but more often than not, we're just combining different open source tools using some sort of scripting language like the ones above to ultimately produce this workflow. And so, of course, there's many challenges with doing this. Maintenance is a big issue. You know, you're very reliant on whether or not you followed some sort of standardization. And ultimately, this method of running a workflow is not very scalable nor flexible. The execution part of the workflow is also quite difficult in terms of how it was traditionally done. So there's multiple environments that we might want to execute on. More often than not, you're executing locally when you're developing your pipeline or workflow. But when you get it to, heavier analyses, you might be doing this on a remote server. You might be using a cluster or maybe some sort of specialized system. And the limitations start to really rank up when you have to determine and implement the ability to execute your scripts in various different environments. So it can be quite complex. So let's summarize what these common challenges are then. So the three challenges that I mainly see are reproducibility, scalability, and portability. So when we talk about reproducibility, traditionally we're dealing with complex data and very computational methods. So it's quite difficult to reproduce these results, especially if we're just stringing these different tools together. So we want to ensure consistent results across different runs and environments. Scalability. We want to be capable of handling the increasing amounts and complexities of data. And this is so often true with bioinformatics, especially with the exponentially growing sizes of biological data sets. And lastly, we want to rectify how difficult it is to maintain software compatibilities across various platforms and systems. So if we can make it easily adaptable to different computational environments, we'll have solved a major challenge in designing bioinformatic workflows. So what are the solutions out there? Well, we can categorize them into two parts. We have our workflow frameworks, which are much more software oriented in that they fall in that sector more so than the research sector. So these include things like Argo with Kubernetes, Airflow with Python. These are great solutions, but when we're talking about the research field, we more so see the use of workflow managers. So these are tools that actually let us automate and manage the entire workflow process. So some of the key players include SnakeMake, WDL, and of course Nextflow, which we'll be talking about today.
So rapid prototyping. This means that we can quickly iterate on our designs of workflows, which is especially important in our research environment. And this, along with the integration of tools for code sharing like GitHub, lets us write multitude versions of this workflow. Of course, reproducibility is a big thing. And how it achieves this is through Docker and Conda for environment consistency across platforms. So this ensures results can be replicated, and we'll see a little bit later exactly how we can use that ourselves. Now, portability is especially important in a workflow manager that's meant to work seamlessly. And so Nextflow provides an abstraction layer between your pipeline's logic and the execution layer. So it can work out of the box with many different platforms. Nextflow also is implicitly parallel thanks to its programming model. So we can take advantage of that to really speed up our workflows. And then lastly, it's really reliable. So they built it into the system that your execution can resume from intermediate steps regardless of the reason for failure. So all these reasons come together to offer a really modern approach to designing and running workflows. So what are the key concepts with Nextflow? Well, you heard a bit in the last slide, but Nextflow mainly consists of two parts. It has a workflow orchestration engine, which manages the execution of tasks and workflows. And then the second part is the domain specific language. So this is the actual scripting language that you use to design your workflows. And that's very user friendly, which means it's accessible to even those with limited to no programming experience. And so with these two parts coming together, Nextflow makes it really flexible to easily integrate your various tools and even custom scripts written in other languages. One of the great things about Nextflow is its data-driven design. What does this mean? Well, Nextflow workflows are reactive. So this means they automatically respond to data availability, which streamlines the data processing pipeline. So if we think about a directed acyclic graph as shown to the right here, what this means is we can establish data dependencies. We can say, for example, E, as you see here to the right, depends on processes B, C, and D. And so in that fashion, Nextflow works out of the box where E will actually wait on steps B, C, and D before continuing to execute step F. And the other thing to note about Nextflow is it has built-in Git support. Now, for those of you not familiar with Git, it's a versioning platform for code. And the benefit of this is that we can leverage not only versioning systems for our own workflows and the releases, but also for easily sharing and retrieving community-based workflow. As you saw in the previous slide, Nextflow consists of a spec or scripting language and an executor or the orchestration engine. And what this means is that there's an abstraction between the workflow's functional logic, the description of the workflow, and the underlying runtime, so how it's executed. And so what this means is it's possible to write a workflow that runs seamlessly on your own computer, a cluster, or even the cloud without being modified. You simply have to define the target execution platform in a configuration file. So let's talk about scripting in Nextflow. There are two key concepts to understand Nextflow that enable workflow design, that being channels and processes. So channels facilitate the flow of data between processes in a workflow. And there's different types of channels. So for example, in this diagram, we see a queue channel where we see a queue of data items Z, Y, and X being funneled to the process. Now, the process is the actual working unit of the Nextflow workflow. This is what consumes the data, does some sort of analysis with any number of steps, and then produces an output. And that's sort of exactly what we see in this diagram. And to give you an analogy to really simplify that concept, let's imagine a conveyor belt sushi restaurant in Japan. Channels can essentially be thought of as the sushi conveyor belts that deliver the sushi from the chef to the diner. So the making of the sushi can be thought of as one process, and the eating of the sushi is another. So hopefully that helps simplify that concept. And so now I'd like to invite you to join me in the hands-on portion of the workshop. So you can go to this link and find the instructions for setting up the gitpod environment. So I've already gone ahead and loaded this page up. And as you can see here, you're presented to this github.com page, which contains the code for this workshop. Now, the portion that is of interest to us is located down below in the readme.markdown file. So what you're looking for is this gitpod opening gitpod badge. And once you click it, it'll redirect you to the gitpod dashboard. Now you'll need to log in, which is why you needed the GitHub or GitLab account. In my case, I have a GitHub account, so I'll see this button, but you may see a continue with GitLab account depending on which account you use. So regardless, you will proceed with your account. It'll log you in, and it'll take you to the Gitpod workspace. Now you don't need to change anything here. All you really need to do is click the continue button, and that'll open up the workspace. Now this may take a moment or two, depending on your computer. Really, it's all happening in the browser, but as you can see, it's pretty quick. So just take a moment to look around and get a feel for this environment. This is a code editor called VS Code. Gitpod has slightly modified it so that it works for their system, but essentially we have our file explorer to the left here. We have our code terminal on the bottom, and at the top is where we'll be editing our files. Now, this gitpod environment is pre-installed with Nextflow and its dependencies, but for the sake of showing you how simple it is to set up, let's walk through it. So first of all, let's make a new project directory for Nextflow. We'll call it my Nextflow project. Pardon me, you'll see I make a lot of spelling mistakes, so pardon for that. And we'll enter the project directory, and we'll need to install Java. Now, that might take a while, so we're just going to check that we have Java installed. And there it is. We get some information about the current Java runtime. And then to actually install Nextflow, we just run the following command. And you saw right there that Gitpod needs permission to copy and paste. So I would just allow that for this current session. So if we enter this command right here, this will directly run a script from Nextflow. This will be a bash script where it will download the required dependencies. And then as you can see here, it'll install Nextflow. And it gets installed directly in the directory that you ran the command in. And if we just create a Nextflow file, we'll just use the touch command. We open it up. We'll see the main.nf file. And let's actually try running that empty file. So how do we run a Nextflow file? Well, we need to use the Nextflow command line tool. So we install that. And the way we actually use it is by referencing the binary. So we can just say /Nextflow. Now, Nextflow has many different commands, which I encourage you to find through its training documentation. But for now, what we need is the run command. And to run our Nextflow script, we have to specify which script we're running. So in this case, it's main.nf. So we just type that in after the run command. And if we click enter, it'll take a second. We'll get some information about the Nextflow version, and it'll try launching it. Of course, this is an empty file, as you can see here, so nothing will happen. But we did get an output, so we know Nextflow was successfully installed and it is running. So now that we have some understanding of how to set up and install Nextflow, let's actually proceed with creating our first Nextflow script. So we'll start by declaring a process block using the keyword process and the curly braces. And what exactly is this process block? Well, this defines a set of actions that we want to be executed. So we're telling the Nextflow engine everything within this is one step in our workflow. So the way we're going to do this is declare a name for the process. In this case, we just want to say hello. We'll say hello. Pretty simple. And then to actually do something in this process, we need to add a script keyword. That's denoted like this with the semicolon. Then to actually write the script, we'll need to provide some commas like so. And within these quotations, any command that you have installed on the local device. So in this case, this server is valid. So because we're using a Linux server, we'll use the echo command and we'll say hello Nextflow. And you'll notice I use single quotations because we're using double quotations as the marker for the script. So let's save that file and actually run the command using Nextflow run main.net. And as always, Nextflow takes a second to launch. It gives us information on what's being launched. And you can see, as it's shown here, that because we don't have any workflow definition, Nextflow didn't run anything. So what this is saying is we actually haven't told Nextflow what to do with say hello. All we have is declared that there is a process say hello. We haven't actually put it into a workflow. So let's go ahead and do that. So if we use the workflow keyword and once again curly braces, we can reference the name of our process. So in this case, it's say hello, and just call the process as we would call a function in any other programming language using parentheses. And so if we save that and then try running it again, we see that the process executes correctly. And so as you can see here, we had a couple different pieces of information in the Nextflow logs. We get the name of the process, we get the number of items that have been processed and how many were processed successfully, as you can see by the check mark, and also a hash that references the work directory that it was generated in. So if you look to the left here, you can see that Nextflow actually generated a couple different files. So first of all, there's the log files. So we could go here, see actually what happened when we ran Nextflow. So this is really useful for debugging. And then we can see the work directory where all the things that were run are found. So in this case, we didn't have any output, so we won't see anything like a file. But this is where it would be output. So let's go ahead and close this down. Just minimize this. And let's learn a little bit more about Nextflow syntax. So we'll again make a new file. We'll just call it helloworld.nf. And we'll find it to the left in the code editor right here. So if we open it up, we have an empty file. And let's actually start writing some of the common Nextflow syntax that you might use.
So now let's create a slightly more advanced workflow in Nextflow. And the workflow that we'll create will demonstrate the basic concepts of data flow, process definition, and pipeline execution. So we'll take a string called hello world and split it into chunks of 6 bytes each, convert those to uppercase, and then print them out. So the way we're going to do this is let's first declare a shebang line. And what a shebang line does is it tells the system interpreter how to run the script. So in this case, we've declared that they should use the Nextflow binary. So now let's actually define our first process. We'll call it split letters, and this will be the first part, which will actually intake an input of strings and chunk it into 6 bytes each, saving them as files. So to do that, we'll declare the process keyword, a name. In this case, I'll do in all caps split letters. The all caps is a bit of a convention in Nextflow, but feel free to follow whatever convention you want as long as you're consistent. And then the curly braces. Now, when you're designing a workflow, you're going to have inputs and outputs. So Nextflow has keywords reserved just for that. So we can declare the input keyword and describe to the process exactly what it will take. In this case, it's meant to take in a single value. So we'll declare a value parameter and we'll assign it a variable name of X. So what we've said is the process split letters will intake one single value and store it in the variable X. Then we'll declare an output describing where those files will be found. So in this case, we have to give it a special keyword of path, which is used to denote a file path, either remote or local to the system. We'll tell it what to look for. So in this case, it's going to be looking for a file called chunk_star. And the star is just a regex pattern. So it essentially just matches anything that begins with chunk_. So any file with the beginning with this will be mapped to the output. And then let's add a script section like we did before. Now you don't actually have to declare script. All you really have to do is provide the triple quotation. But just for the sake of being consistent, let's call it a script. So now let's actually add in the script that will perform the chunking action. So I've gone ahead and prepared it right here. Now it doesn't really matter to you what all these commands do. All you really need to know is that you can pass in your variables directly into your script by providing a quotation and passing in the $sign. So we've declared our process split letters, but we have not yet provided a value for X, nor have we created a connection from the value to the process. So let's go ahead and do that. So first we'll declare a parameter called greeting. So params is another reserved keyword, and greeting is just name of the parameter that we're allowing to be passed to the script. In this case, we'll give it a default value of hello world. So now we actually have a value that split letters can intake, but we haven't provided the method for connecting these two. And so if you think back, we talked about channels. Well, this is where they come in. So we declare another variable called greeting channel. So this is another convention. You give the name of the parameter and then _ch. Again, this is up to you, but it's nice to follow conventions that everyone's following. Regardless, we assign it a channel keyword. And we say it's a channel of type params.greeting. So what we've done is we've connected the parameter to a channel, and now this process can consume this channel. So all that channel is really doing is holding the value of params.greeting. So now let's actually create the workflow definition. So we can consume the process, the channel, and the parameter. So we, just like before, declare the workflow keyword and the curly braces, and we can call the function using its name, the parentheses, and this time we're going to be passing in a parameter. So we'll say greeting_channel, and just like that, we've connected our parameter to our process. Now let's add some more details to this workflow so we can actually see something meaningful. We're splitting the letters, but we still want to convert it to uppercase, like we said before. So we'll add another process, and we'll call it process convert to upper, and we'll again provide the curly braces. And in this case, because we're outputting a file, you want to intake a path rather than a value. And we'll output it just to the terminal. So by convention, that would be the standard output. And that's just what that is denoting right there. And then we'll add the script that actually converts our file into uppercase. So 3 quotations. And we can add in our script right here. So notice that all I really needed is the $sign. You don't actually have to declare the quotations, but the $sign lets us reference our input variable. So now we have a second process. Let's use it just like before. We call the function and we use the open parentheses. But now, how do we get the variable out of split letters? Well, all we really have to do is declare it. So we could just say letters channel, which would be the chunked letters, is equal to split letters. So now we're assigning the output to this channel. And then we'll say convert to upper consumes letters channel. And lastly, to actually view this, because we're actually not going to be able to see this, we need to consume the output of convert to upper. So we'll just similarly make a channel called results, and we'll view it by calling a special function called view. It uses curly braces and an iterator to print the results to the console. So before we run this script, let's review what's going to happen. So our script is going to intake a parameter called hello world. It will assign it to a channel of greeting. Then in our workflow declaration, we'll consume that greeting channel, split the letters, which will create various files called chunk. And then those files will be consumed to convert those to uppercase, and then that will eventually be printed to the console. And so now let's actually try running our script. So if we do /nextflow run hello world.nf, we see some output, and we see that our workflow successfully ran. Oh, but look at that, there's a problem. Hello world is being output exactly like it was set in the parameters.greeting. This means our workflow actually isn't doing anything. And so the reason why this didn't work is because we're actually not consuming the output of split letters correctly. So we need to transform the letters channel into a way that the convert to upper can consume. So what we need to use is something called flatten. And what essentially this will do is it will take the group of outputs uh, produced by letters channel and break them down to emit them as individual items. And so that means that convert to upper can consume each one of them as a separate input, and it will correctly produce the output that we expect. So if we run Nextflow run hello world.nf again, we can see here that it actually did successfully split the word. So now that we have some basics on how Nextflow works, let's actually try making a proper bioinformatics pipeline. So we're going to be making a metagenomics-based taxonomic profiling workflow, which performs several steps. This is actually derivative of another workflow that I created called MetaSense, which I have linked right here. So it's a much simpler approach, which I thought would be more appropriate for this workshop. So it's revolved around 4 steps, being read quality determination using FastQC, taxonomic classification via Kraken 2, species relative abundance determination using Bracken, and then finally the aggregation of all the pipeline outputs into a report using multi-QC. So just, for those that aren't familiar with it, metagenomics is a really fascinating and rapidly advancing field. It essentially involves analyzing the collective genome of microorganisms from an environmental sample. So this could be soil, seawater, human gut, any sort of whole collection. And so the primary goal with this is to understand the microbial diversity and functions in a specific environment. So there's several key processes, but for us, we're mainly focused on the bioinformatics part of it, where we're analyzing the sequence data to identify which organisms are present, which would be taxonomic classification. And, what are the applications of this? Well, all sorts of things. You could discover new enzymes. It's better, we can understand microbial life. We can study the human microbiome. So it's really widely applicable. So let's take a look at some of the tools that we're going to be using. So FastQC, this is a popular tool for quality controlling of sequencing data. So to the right, you see an example report that would be output by this tool. And it's really meant to be user friendly and just provide reports on the quality of your sequences. Next, what do Kraken and Bracken do? Well, so Kraken is the workhorse of this pipeline. It does rapid k-mer-based classification of sequencing data using a known database of k-mers. And then Bracken is actually just an extension of Kraken. That actually does the abundance measurements of the data output by Kraken to give us, proportional measurements of the species presence within a sample. And then lastly, we have multi-QC. So this is an aggregation tool for bioinformatic analyses. So there's several key features. It supports so many bioinformatic tools, like you name it, they have it. The reports are interactive, and really, it's just a great tool for creating summary reports. So now that we have an understanding of, the tools that we're going to use and exactly what kind of workflow we're going to make, let's go back to gitpod. So now that we're back in gitpod, let's try creating that workflow that we just talked about. So we'll create a new file. This time we'll use the GUI, so we'll just click the plus button right here, and we'll call it taxonomic classification.nf. And just a note that you can always refer to the folders that contain the actual code that we're running through, so you can see the complete code if you ever want to reference it. And let's think about what we need. So first of all, we want to run a taxonomic classification workflow. So we need some sort of data set. Luckily, I've already provided that. You can see it over here in the data folder. So in this case, let's try analyzing the gut files. So we'll declare a parameter called params.reads because these are our FASTQ reads. We'll specify where they are. So in this case, we can find that out by just right-clicking and copying the path. And there it is. And we want the gut files. And you'll notice that there's two files. So when we're working with sequencing data, often they come as pairs. So we need to actually get both files. And in Nextflow, because it is primarily a bioinformatics-based workflow manager, they've thought of this. So we can actually use regex patterns. So we can say that we want to match the files that have begin with gut and are preceded by a number being 1 or 2. And this lets us grab both of those files. Now we want to declare a channel for these reads, just like we did before. Call them channel read pairs because that's what we're outputting. And we can use a different method on the channel to retrieve this value. So this is something that's nice about Nextflow. They handle all different kinds of cases in terms of variables that you might be inputting. So this one is specifically meant to handle file pairs, but if you look through the documentation, you'll find much more. So we've declared the reads and we've declared a channel that will consume those reads. Now let's actually define the first process that we'll use to analyze this data. So we'll declare the fastQC process. Just like before, we'll give it a input variable. Now, in this case, this might be a little bit confusing for those of you not too familiar with programming, but we'll be using a tuple. So what exactly is a tuple? Well, the basic concept is that it's a way to group together different pieces of data. So it's just a small container where you can store items of different types. So in this case, channel.from file pairs is outputting a tuple. So that's what we're expecting fastQC to intake. So we'll need to consume those values. Now this outputs a value of sample ID and reads. So what we'll do is we'll consume a value for the tuple being sample ID, and we'll consume a path for the reads. And so this will work for each of the FASTQ files that we're inputting. Then, of course, we need to output the data somewhere. So we can just say output. It'll be a path output. That's what fastqc outputs. And we'll just declare it as a fastqc prefix. We'll give it a name of the sample that's being passed in, sample ID. So again, we have that dollar notation to pass in variables, and we'll just call it logs. And then, of course, we have to do the script that actually does all the work. And so now we can actually add the commands in for fastqc. Now, the details of these commands aren't too important. Really, all you need to know is that we're making a directory for the output of fastqc, and then we're actually running the fastqc command. So let me just minimize this terminal here. And we can see here that we almost have all the components to run this workflow. All we need now is the actual workflow declaration so we can run fastqc. So we'll say workflow will actually move the channel read pairs into the workflow just to make it neater. This is perfectly valid. And then we'll say that we want to run fastqc. So all we have to do is say fastqc, call it like a function, and then pass in the variable, which would be channel read pairs. And that's our workflow, or at least the first step of our taxonomic classification workflow. So let's actually try running it now. So we use the same command as before, nextflow run, but in this case, we're going to be passing in the taxonomic classification workflow. And as you can see, it's running and we get an error. And this is expected because in our system, we actually haven't installed fastqc. And so without having the dependency of fastqc, this workflow would never work. So how do we solve this? Well, we simply just need to install fastqc. Now, if you think about it, we're going to have to install dependencies for our other tools as well. This can get quite complicated, especially when each of these has their own process. So how do we manage this? Well, this is where Docker comes in to the picture. So what is Docker? Well, Docker is a platform for developing, shipping, and running applications in isolated environments. And we call those isolated environments containers. So what is its purpose? Well, what Docker does is it ensures consistency across environments. So that old saying of it works on my computer, so it should work on yours as well. Docker really helps in making that statement true. So let's talk about some Docker concepts. Essentially, Docker revolves around these four stages. the Docker file, which is the spec that describes the software's uh, dependencies, how they need to be installed, and everything around that in terms of configuration. Then there's the build step, which produces an image. And the image is just a standalone package that includes everything that we just described. That image can then be run on the command line, which produces the executable unit called a container. And lastly, we have registries. And registries are sort of online places where we can share and manage Docker images. So altogether, this makes it really easy to package our tools and share them with different people. And so what are the benefits in bioinformatics? Well, it's mainly these four things. It standardizes the execution environment. It simplifies the process of managing dependencies. It really lets us be scalable and portable, and ultimately, it drives collaboration. So what about with Nextflow? How does this fit in with in that world? Well, Docker lets us easily add new tools by just providing a Docker file and producing a Docker image. That automates the dependency handling and ultimately makes it so we can simply execute on any environment. So you can think of Docker as really the core mechanism behind Nextflow's seamless execution. So let's actually make a Docker image. So we're back in gitpod, and to design a Docker container for running fastqc, we need to first create a Docker file. So we'll just say uh, Docker file, and you can see it has no extensions. So now let's actually build a Docker file. Now, each Docker image consists of a multitude of commands. So I'm just going to copy and paste what the file and image is going to look like, and we'll go through each of the steps. So first of all, each Docker file requires a parent image. This will tell Docker how to build the image and where it's building it from. So in this case, we're using an image made by Ubuntu. So this would be hosted on Docker Hub, which is the registry hosted by the Docker platform, and the version of Ubuntu that we want. Then we're declaring an environment variable. So you might have certain environment variables that are specific to your tools. If you're not familiar with this, it's not too important. But in this case, the reason why we've declared this is we want to say that all the install steps are non-interactive because they are being installed command line. So we don't want to be prompted for anything. Then we can declare a work directory. So this is more so useful for application development, but it's also an organization step. So we can say that all of our app downloads and dependencies will be stored in the /app directory. Then we have the run command, which really does the bulk of the work. This is where our dependencies actually get installed. So I've split them into two steps here. First, we have the dependencies that fastqc needs to actually work. So it has its own dependencies. And then we have the actual install step for just downloading and installing fastqc. So as you can see, for example, we actually had to install wget in the previous step because it doesn't come with the image. So just something to keep in mind. It's kind of like we're building an entire system from scratch. But in doing this, we're really standardizing the way that we manage our dependencies. And lastly, we're just running a default command of fastqc. So when we run the container, we actually see something. So let's actually build this container. The way we do that is using the Docker command line tool. So if we type in Docker, we'll see that it's already installed in the local system. And there's a bunch of flags you could use. But in this case, we want to build this Docker file. So we'll say Docker build. We have to tag it with a name. So in this case, we'll call it fastqc. And we need to give it a version. For the sake of time, we'll just call it latest. So it doesn't have to be a number. And then of course we need to tell it where the Docker file is. In this case, it's in our current directory, so we can just give it a dot. Now I've already installed this, so this is going to be super quick for me, but this is going to take a while for you. So I would just maybe pause the video here and then come back to it when you've reached this part. So now that you've reached this part, let's actually try running this image that we just built. So the way we can do that is we can say Docker run, and we can specify the name of the image. So in this case, it was fastqc latest. Pardon me, this is actually the tag, not the name. And we give it a command. So in this case, the fastqc command is just its name, and we'll pass in the version. So we're just going to confirm that it was actually installed. And there you go, we get an output. So we can see that fastqc was successfully installed. Okay, so that's all great, but how do we actually use this in our Nextflow script? So let's open up our script, and you can see that I've added a container directive to our process. So this is just telling Nextflow that we want to run this process using the container that we just built, being fastqc latest. So now how do we actually use the Docker image that we just created? Well, we can just tell Nextflow to run the workflow with fastqc, the image that we just created. So we just provide the with Docker command and the name of the image. So in this case, it's called fastqc latest, fastqc colon latest, pardon me. And if we click run, you can see that this time it actually is running fastqc. And if we look for our outputs, we go to our work directory, we look for 06, and we look for 5adc, which is this one. We'll see a folder called fastqc.logs, and we'll see two different HTML files. If we click it, we'll only see this. That's because we're in gitpod, but we can actually go live using this button, and we can open a preview of the HTML file to see our fastqc file. So let's actually just search for this. We can just copy the directory name. So we'll copy path, search for it. It's not coming up. That's okay. We can just do it a different way. We can go under the Nextflow project, go to work, go to 580C. And if we go to the gut logs, there's our HTML file. And if we move this over here and just minimize our terminal, you can do that using Control tilde. And there's our fastqc file. And we can look at the quality scores, and they look pretty good. And yeah, that's it. So we've successfully made the first step of our workflow. So now let's continue on with the rest of the workflow. So we'll close this fastqc file and open back the terminal. We can stop the HTML server by clicking the go live button again. And now let's add the Kraken process. Now the rest of the processes are essentially the same. So let's actually just go ahead and pull up the entire workflow and add it in. So we've just copied and pasted it right here. And some of you are probably thinking, how are we going to get these to work? Do we have to build the Docker images for each one? And actually, no. So the cool thing is that there's already Docker images out there publicly available images for each one of these tools. So FastQC, the people who publish FastQC, they've made their own Docker container for this, and so on and so forth. Of course, some of these are custom. So for example, Unpacked Database, uh, this will luckily work locally, so we don't really need a container image for it. But regardless, for most tools out there, there's a container. And so the nice thing about Nextflow is that we can actually provide a specific container image to each process in the step. And so the way we're going to do that is by providing a container directive to each of these processes. So if we actually go over to the final.nf file, we'll see that we've already defined these. So we can just copy that over and then we can talk about it over here. So the container directive, as shown here for FastQC, is pointing to a specific repository. In this case, it's quay.io. And there's a organization called Biocontainers that publishes the uh, images for various popular bioinformatic tools. So for example, here we're using their FastQC image. So now let's actually run the complete workflow. So we've already added the container directives to each process. Now let's create a config file called nextflow.config, which will actually let Nextflow know to use Docker. So it's a simple configuration. The details of these configurations are found on the Nextflow reference documentation. So it's not really important to memorize any of this stuff. But all we really need is this enabled command. This is just an extra thing for gitpod. So that will set the configuration to Docker whenever we run Nextflow. So now all we need to run is the script, and additionally we have to pass in the specific pathway of the files. And the reason why we need to do this is because the path is actually incorrect here. So we get the path by looking for our files. So in this case, it's under the data directory. We can right click and then copy the path. And if I just close this, delete this right here, you can see that it will give me the following path. Now, of course, this is only the path that got one. We want both, so we add a little rejects pattern so it can do 1 and 2. So we run the script, and because this is running quite a complex workflow, this is going to take some time, but let's actually investigate exactly what the logs say and what is happening. So as we can see here, it starts by running fastqc. At the bottom, we see that it's staging a foreign file. So this is actually downloading that remote file. And oop, we got an error, but this is actually expected. So let's go back to the logs up here. So we can see that they staged the remote file that we wanted to download. It successfully ran through all the processes. And really what failed was the bracket step. And so if we go down and we look at the error, we can see that the reason for failure was actually because there were no reads found. And this is an unavoidable debugging step with Nextflow. Because we're joining and sort of gluing together different tools, we're reliant on the error handling of each of those processes and the tools within those processes. So luckily, Bracken actually tells us that, hey, we couldn't find any reads for your Kraken report. So really, this isn't an issue with our workflow. It's more so an issue with our data input. So how do we actually solve this error? Well, we can run it with a valid FASTQ file or pair of FASTQ files. And actually, this is where I'm going to leave it up to you guys, but I'll give you a little hint. So typically, we wouldn't want to download these files because these files could be huge. So we want some way to pull in external data and use that in our workflow. So typically in Nextflow, you would use some sort of sample sheet. So for example, if you go to the following link, github.com/mswingen in a sense. And I'll leave a link to this in the README for the GitHub repository that hosted this gitpod link. You'll actually find an example of how I've done this in a more complex workflow. So I would encourage you guys to try to figure out how exactly you can take this CSV input. So if we open it up right now, you can see that it gives us links to FASTQ files. So try to figure out how exactly you can use these files in combination with the appropriate database. So in this case, it's a viral K-mer database to get an output. Yeah, so in conclusion, that's the end of our workshop. So what did we learn? Well, we learned some concepts of Docker and Nextflow. We learned how to write workflows with Nextflow and also how to write Docker files. We saw how we could design a basic bioinformatic workflow with Nextflow, and then how we could use Docker images to really streamline that process. And so where can you take this now? Well, I would encourage you guys to check out NF Core. So NF Core is actually a community behind Nextflow, where they regularly publish modules and pipelines for creating bioinformatic workflows. So, for example, with the modules or some of the processes that we looked at today, such as FastQC, Kraken, Bracken, and etc., these are actually readily available. You wouldn't actually have to even design them. You just have to pull their data using the NF Core tool. And also with that, they have strict guidelines and standardization of workflows. So it's a really great place to get started or explore further with Nextflow. And lastly, I did briefly mention uh, that the workflow that we designed today was derivative of another workflow. So here's the link to that, and that's also the location of the sample sheet file that we just talked about. Thank you so much. Hope you guys learned something, and have a great day.